All right, so here we're going to define the inverse tangent function. So tangent, just to make sure we're on the same page here, tangent y equals tangent x. So this graph, right, passes through the origin, kind of looking like this here. We've got vertical asymptotes, pi over 2, negative pi over 2. Okay, we're going to do the same thing. This function is periodic. Another vertical asymptote, x equals 3 pi over 2. And so on. And you do this, until you get tired of drawing out this graph. Now, for inverse, not only do we have to have it pass the vertical line test, which it clearly passes vertical line test, but you also have to pass the horizontal line test, which if you did right here, it would fail because it passes through infinitely many times as far as you wanted to go out that way. So what we're going to do is we're going to restrict the tangent function. We're going to restrict it to the interval negative pi over 2 to pi over 2. And we don't include the negative pi over 2 and pi over 2 because those are at vertical asymptotes. You try to plug that in, you're going to be dividing by 0. No bueno there. Okay? So if we restrict it here, then these parts go away, and all that we are left with is what's in the middle here. Okay? So we restrict here, that's my domain. And then my range, well, what's the lowest we go? We go down to negative infinity and we go up to positive infinity. So the range goes from negative infinity to positive infinity. All right? So the inverse, we swap the x with the y, right? So the inverse tangent is y equals tangent inverse x. Sometimes the textbook calls it arctangent x. So if you see arctangent, that's just talking about the tangent inverse function. All right. How is it defined? Well, this is defined from negative infinity x to positive infinity. So any value you can plug in, and the y value now, the range goes what? It goes between negative pi over 2 all the way to pi over 2. Okay? So what does this look like in the graph? We literally take our graph and we turn it on its end. So instead of vertical asymptotes, now we're going to have horizontal asymptotes. So horizontal asymptote at y equal pi over 2 and y equal negative pi over 2. And it's going to look something like this. Interesting graph here. This graph, the curve here is always increasing for all real x. So it's interesting property where you've got a function that everywhere it's increasing. Pretty interesting idea there. So this graph is y equals the arctangent or tangent inverse of x. Okay? We can plug in any value for x and it spits out some value y. Okay? Between negative pi over 2 and pi over 2. So what I want to do now is I want to find some exact values. So let's find exact values of, well, let's try tangent inverse of 1. Okay. Now think back to arctangent versus tangent. Okay. So trig trig tells you the ratio of sides, okay? Trig inverse tells you the angle, okay? So trig inverse here tells me what the angle is. A trig function like tangent, cosine, secant, whatever, those are trig. And then tan inverse, cosine inverse, secant inverse, etc. Those are trig inverse. That's what I'm talking about there. So if I'm looking for an angle, I'm going to say set this equal to theta. I don't know what theta is, but you know what? We're going to figure it out. Now, what do we know about theta? Okay? What do we know about theta? Well, theta is going to be restricted between what? That output, the lowest to the highest value right there, right? So theta is going to be restricted between negative pi over 2 and positive pi over 2. Okay? So I know that that's the case. Now, if I know that this is true, then if I tangent both sides, so tan inverse of 1 equals the tangent of theta. So I tan both sides. I get what? Those cancel. I get 1 equals the tangent of theta. Now, what value, you have to ask yourself, what value for tangent theta, what theta can I plug in and it gets me 1? So look at my original graph here. So this is y equals the tangent of theta, right? Okay. What theta can I plug in and I get an output of 1? Well, that theta that I plug in is theta equal to pi over 4. Okay? So theta equal pi over 4 tells me that I get a tangent of 1. All right, now, is pi over 4 between pi over 2 and negative pi over 2? Sure is. So I think we're okay here. All right, so theta equal pi over 2. So the tangent inverse of 1 is equal to pi over 4. Okay? Now, what about this one? Say I had tangent inverse negative square root 3. Okay? Set it equal to theta. Let's run through the same game here. I want, well, if I tangent both sides, I get negative square root 3 equals the tangent of theta. Now, how do I get negative square root 3? Well, if I'm looking at this graph here, if it's negative, if it's negative, all right, then, you know, I know I'm going to be on this side somewhere. So it's some negative theta. Okay, so it's a negative theta value. So what do we know? This negative square root 3 down here is the same as this positive square root 3 up here. It's symmetric, right? It's odd. Okay, symmetric about the origin. All right, so do I know a tangent theta that gets me square root of 3? Well, we got to think back to the unit circle, right? Let's think back to the unit circle. Okay. When I do my unit circle, what do I have? I got square root 3 over 2 comma 1/2. I've got 1 over square root 2, 1 over square root 2 here. And then I have 1/2 and then square root 3 over 2. Tangent theta is y over x. So if I look at this, okay, square root 3 over 2 divided by 1/2. Keep change flip tells me that this gives me square root 3. So this angle right here, if you remember, this is pi over 3. So that gets me positive square root of 3. If I went down here this way, that would be negative pi over 3. Okay? So theta equals negative pi over 3. Now, how do I know it's negative pi over 3? Well, I need to make sure originally theta was restricted between pi over 2 and negative pi over 2. Okay? And since negative pi over 3 is between those, then we got our answer. All right? So maybe it would be helpful if we wrote out a table. That way you'd have these all memorized. Hopefully you have them memorized, but if you don't, this is a good chance to see everything. So negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6, 0, and then we'll do pi over 6, pi over 4, pi over 3, and then pi over 2. Okay? So what are the values for tangent? Well, we look at the graph, right? At negative pi over 2, we have a vertical asymptote, so this is undefined. At pi over 2, we have a vertical asymptote, that's undefined. Now, negative pi over 3, we just figured that one out. That was negative square root of 3. Negative pi over 4. When I look at this, it's the same thing. One number divided by itself. Anytime I divide a number by itself, then it's going to give you the same number. Now the difference with this one down here is the x value is positive, so that's 1 over square root of 2. But the y value is actually negative. So it's the number divided by the negative of itself. So positive divided by a negative or negative divided by a positive, that's going to give you a negative 1. Okay? And then if I plug in pi over 6, I'm going to get negative square root 3 over 3. Where did that come from? 1/2 divided by negative square root 3 over 2. Actually, I think it's negative 1/2 divided by that other one. So keep change flip gets me negative 1 over square root of 3, which when you simplify, you get that negative square root 3 over 3. 0 is 0. And then now it just becomes the positive. So square root 3 over 3. And then positive 1, and then positive square root 3. Okay, so those are values you really need to memorize, okay? Really, you've got to memorize these, and you can derive them from your unit circle here, remembering that tangent is y divided by x, okay? So all those values come from your unit circle. So make sure that you learn those values. Now, if you're going to do composition, okay, of functions for tangent, now there's a couple rules here. F inverse of f of x, which is equal to tangent inverse of tan x. This equals x as long as x is between negative pi over 2 and pi over 2. Okay? And then f of f inverse equals the tangent of arctangent, which equals x, as long as x is a real number. So anything from negative infinity to positive infinity. So anything here will work, okay? So just keep that in mind as you're working through composition of any functions you might run into, okay? All right, guys.